Alright, this table is not linear and is not constant. This table is linear because the common difference is 2 on the first difference. This one is not linear and is not quadratic. Guess what this last one's going to be? Quadratic. Alright, so here it is. The XY table. I want you to see the sequence that we were working with. It's the h of x one, where we have 2, 5, 10, 17, and 26. Okay? We're going to put this on a table. 2, 5, 10, 17, 26. First stage, 2, 5, 10, what I said? 2, 5, 10, 26.
17.
All right, 1, 2, 3, 4, and 5. What I want you to do is find the first common difference and then find the second common difference. Find the first common difference and then find the second common difference. Cartier. Where? Not here, right? Oh. Gotcha. All right. To get from 2 to 5, add 3. 5 to 10, add 5. 10 to 17, add 7. 17 to 26, add 9. That's the first common difference. Is it linear?
No.
Absolutely not. Azaria and Amanda.
I think she in PSAT.
Okay. All right, now the second common difference, add 2. To get from here, add 2. To get from here, add 2. Y'all see that? Okay. The second common difference is the same. The second common difference is the same. Therefore, this is a quadratic. Now, this is important. It's so important I'll put it on an anchor chart at some point. If the second common difference is the same, it is a quadratic. Open Desmos. Alright, quadratic sequences. The first sequence we had was 2, 4, 8, 16, 32. We found the first common difference. We saw that it was not linear. We found the second common difference and saw that it's not quadratic. The second function we looked at was 2, 4, 8, 6, 2, 4, 6, 8, 10, 12. That is a common difference of 2, therefore it is linear. The third one we looked at, the first common difference was not the same, therefore it is not linear. But the second common difference is the same, so we, in our expertise, are going to say, oh, it's a quadratic. Now we're going to go to Desmos and we're going to make the equation for the quadratic. Alright, and we're going to put this in, I'm going to write down the steps on how to do this because it's going to take some practice. Alright, step 1. Put in your first ordered pair. 1, 2. Put in the ordered pair. After you enter the ordered pair, you're going to click the widget and get the table of values. Got that part? You're going to enter the other values into the table. That gives you the points. After you plot the points, over here under this number 1, we're adding some regressions. The first regression that we're going to add is the linear regression. That just means we're going to write the equation for these points in slope-intercept form. If we were to write the equation in slope-intercept form, it would be y equals 6x minus 6. But if you look, you'll see that the line is not really on the points. That's because we had already said that it's not linear. So because it is not linear, we need to change the type of line that it is. Come over here, and instead of doing linear regression, we know that it's a quadratic, because the common difference of the second common difference is 2. All right, so now, once you click the quadratic regression, you have the equation for the quadratic. Write down that equation. Okay. X squared plus 1. Uh-huh.
What's the equation that you did for the graphing? I was getting my computer.
Okay, so to create the graph, we use these values. All right, so to write the equation, enter one ordered pair, then click the widget to get the table. You enter all of the values and press, I don't know how to describe this. Right here. Over here on this side, once you put in the values, there's a little symbol to put in your regression. Let's see what we call it. Like I put in the order pair, and then I click this table button, and I press table. After I enter a few more values, I can press this little flag button under the 2. So press the flag under the number of the entry. Press the flag next to the entry to get the equations. Now note that this is not a linear because they're not points on the line. This is a quadratic.
Please, I need Eric Ortiz for checkout.
Oh man, okay.
Okay, thank you.
All right. Eric, I'll record this and put it on YouTube for you. Let's go back to here. All right, the equation is y equals x squared plus 1. What's the problem? That's a quartic regression. We want quadratic regression. Be sure you choose the right one. You want quadratic and not quartic. Huh?
If it's linear, we don't use this. We don't use quadratic regression.
If it's linear, you use linear regression. If it's a quadratic, you use quadratic regression. Okay, now. Yeah, so over here, once you put in the table of values, there'll be a little icon right here that'll say regressions, add regressions.
Okay.
All right. Now, about this graph, does it have zeros?
No.
No, there are no zeros. Does it have a vertex?
Yes.
Where is the vertex? Cell phone. And headphones. Chop chop, we got a quiz to take and you wasting my time.
Don't, Just say your
Thank
name.
you. Come on, come on, come on.
I'm turning them off.
Okay, you wasting the whole class time. Are you done?
I didn't know what you did.
Alright. Now, this one does not have any zeros, but it has a vertex. The vertex is at almost 0, 1. It may be 0, 1. Okay, moving on. Let's tie it all together now. Huh?
The equation right
Uh-huh.
there, how do we get y equals?
I think you have to choose one of these. You asking how do we get that?
You said this was the equation, but
Yes.
or.
Oh, because the 0 is not there, so I don't write it.
Oh.
Yeah, that's all. I just didn't write the 0. Huh? The equation is y equals x squared plus 1 because the 0 is not there. I'm sorry? You won't see the flag unless you have just the table of values. So if I delete this and I put in 1, 2, and then I click the widget to get the table of values, I got to put in more values because it needs multiple points to form a line. So 2, 5, 3, 10. And then you can click this little flag icon over here. That's really a line with some dots on it. It's not a straight line, so it's not a linear regression. It's a quadratic regression. All right. Do you all remember doing this assignment?
No, I do.
All right. Well, some people did because you were already in here. But if you came in late, then you probably did not see this. All right. So what's on here is good. Do you all see this right here? This is a quadratic. This one, let me find another one. This one right here, this is a quadratic. Please write down this equation. Y equals x squared plus 3x minus 4. Y equals x squared plus 3x minus 4. Write it down.
Y equals x squared plus 3 squared.
What I said.
Y equals
X squared plus 3x minus 4. Y equals x squared plus 3x minus 4. All right. Now, what we're going to do is tie together quadratics and factoring polynomials with area and perimeter. If you pay attention, you will understand it. This is almost college level math though. So you really got to pay attention to understand it, okay? Here we go. We're going to go into Desmos and we're going to type this in as it is written. Clean this up. Y equals x squared plus 3x minus 4. Alright. Now, this is so cute. We have zeros and we have a vertex. The 0 is at -4 and 1. One of the things that I told you that we needed to remember is that quadratics have the same second common difference. The second thing I need you to remember is right here. Zeros are the solutions to the quadratic and the factors are written as opposites. What are you saying? I'm saying that this 1 and this -4 will help us form the factors because the factors lead us to the zeros and the zeros are the solution. It is going to be x plus 4 times x minus 1. equals y. That's the second, that is the factored form of the quadratic. You'll know the factored form is where you find the zeros for the solution. It's another way to write the quadratic. In other words, on this paper, give me a second, when you all matched up, when you matched this trinomial to this expression, you knew that they were the same. That's why we put them together. We also went over to Desmos and we typed in the second one as it was to see if it matched. And I said, well, if it's the same line, then you know that that's the answer. All right, so we're going to type in y equals x plus 4, parentheses, x minus 1. I do not have the same line because I have a mistake. All right, my mistake is right here. Now, two equations, one line means that it's the same graph. Everybody okay with that? These are the zeros. The zeros are the opposite of the factors. For the factor, I put x plus 4 because if I solve it, x is going to be equal to negative 4. For this one, I put x minus 1 because if I solve it, I'm going to get x is equal to positive 1. That'll come when we do the quadratic formula. If you solve x plus 4 equals 0, you're going to subtract 4 from each side, and you'll have that 0 value, which is right here at negative 4. So, keep in mind, zeros are the solution to the quadratic, and factors are written as the opposite. It's only 5.
We'll just go for a major
It's a minor.
in the algebra.
Yeah.
So where we gonna do that?
When we finish.
Wait, can I see that lab? Oh, never mind. I wrote it down.
I didn't. I'm going to write it down now. Oh, my back hurt. Alright, so y equals x squared plus 3x minus 4 is equal to y equals x plus 4 times x, what did I say, minus 1? Yeah. Minus 1. And we know that that is the case because the quadratic crosses the x-axis at negative 4. Kingston, get out. Go find Mr. Cleveland. Take Elijah with you and tell him that I said y'all can't come back until he walk you back in here because y'all won't stop talking. This is where that graph crosses the x, right? At negative 4 and positive 1. So the factors are written as the opposites. I'm gonna come around and ask y'all this question. So make sure you can answer it. Okay. The vertex is down here at negative 1.5 and negative 6.25. So the vertex is like somewhere over here. That part is not important right now. This 0 is at negative 4. This 0 is at positive 1. Because the zeros are where they are, the factors are written as the opposites. Factors, these are the factors right here, x plus 4 and x minus 1. The factors are the opposite of the zeros. Put them in parentheses. In parentheses. Now, we have enough information to write a quadratic ourselves before we add on. there is a quadratic and it crosses the x-axis at 5 and 6. If it crosses the x-axis at 5 and 6, what will be the two factors? That's about what your grade looking like. We ain't playing today. If it crosses the x-axis at 6 and 5, keep playing. I'm so glad you think it's funny. Then the factors are going to be x minus 5 and x minus 6. Go back to Desmos. Clear it out. The quadratic is
I think it's this one.
Let's do x squared. I want to do that one. X squared, 6 and 6, 6 and 8, x squared minus 16x plus 48. X squared, we got to add on, so this is going to be it, plus 16x plus 48. What is the factored form of the quadratic? Here's the quadratic. What are the factors for it? Remember, the factors are written as opposites of the zeros. Go to Desmos, type in this equation, find the factors, and write the factors in parentheses as opposites. 16x plus 48. Y equals x squared plus 16x plus 48. Thank y'all for working hard today.
I got a question.
What's the question? Oh, let me say this before you say that. Here's what I found is an issue. Some people on the quiz, when they get ready to look for the zeros, because the graph is so zoomed in, they're not noticing that this line right here is not the x-axis. And so they want to pick points like here, and then they want to pick points like right there. But I'm saying, look, no, that's not the zeros. Remember, the zeros have to be where it crosses the x-axis. So you got to zoom up, pan up, and find where it crosses this line right here. That line is called the x-axis. Find where it crosses the x-axis. This one crosses the x-axis at negative 12 and negative 4. It is like that.
Oh.
It's like that. All right, who can tell me what the factors are? How you going to write it with the parentheses? What would be the new equation? Uh-huh. Hold on, Blake. All right, y'all saying two different things. Azar, you go first. All right, Blake, say yours. All right, is it 2 or is it 4? 4. 4. Right here. 4. Okay? You got the equation written right? Uh-huh. Where'd you get the 2 from? X plus 12 and x plus 6. No. 4. Same line. All right, now let's add on. Whew. Over here, I'm going to leave this up, but you got to be able to make sense of it. Zeros are the solutions to the quadratics, and factors are written as the opposite of zeros. Now that makes sense, correct? So if you have a graph and it crosses at negative 3 and positive 4, you can write it as x plus 3 or x minus 4. That makes sense to everybody. Who say no? No? You see where it's crossing? This is the x-axis. -3 and 4. All right. -3, how do you write the factor for it? What do you write? Parentheses? All right. How do you write the 0 for this one? I mean the factor. Parentheses? X minus 4. All right. Look. Here's what you have. Now, ask you a question. Do you remember how to find the area and the perimeter?
The area you multiply and the perimeter you add on sides.
All right. Area you multiply. Perimeter you add all the sides. These factors are the sides of the rectangle now. These factors are now the sides of the rectangle. They are x plus 3 and x minus 4. If we do the math, that will get us to this quadratic. If you multiply these two, you can stay over there, I'll come and write it. If you multiply these two by making this box, y'all remember this box? Nadia, sit up. This is the box that you use to multiply and you get this. You do not have to know how to do that. What you need to know how to do is put this in for y equals, put this in for y equals. Make sure they match. Make sure you get the same line. If you don't get the same line, that's not it. Now, let's talk about perimeter. To find the perimeter, you add all the sides. There are 4 sides to this rectangle. They are x plus 3 plus x minus 4 plus x plus 3 plus x minus 4. When you add all of those together, you get 4x minus 2. You cannot check this with Desmos graphing calculator. You can check that because these two are equal. These two are equal. I mean, now technically you could put this in for y equals and put that in for y equals, and if it comes out to be the same, then you know this is the answer to that. But you don't really need that because if you know how to add, you know how to add. All right, let's look at some of these problems that are on the quiz so I can make sure we can tie it all together. You're going to have 20 minutes. If we get to it, we get to it today and start on it. And if we don't get to it and start on today, you take it first thing tomorrow. But I want to make sure that you're fully prepared. All right, here we go. All right, take a look at this problem. You see that there are 2 rectangles here. One of them is rectangle A, the other one is rectangle B. This first question is asking us to find the perimeter of the rectangle. So we're going to come over here to our paper and we're going to set up a problem that will lead us to this answer so that we can make a 100 on this quiz with no frills. No frills, no fluff. Quiz review. Number 1. The first rectangle has dimensions that are 6x plus 3 and x. We have to find the perimeter. To find the perimeter, you add all the sides. There are 4 sides to this figure. We are doing this quiz review. Are you taking a nap? You taking a nap?
I'm literally doing. Her eyes was open. Like.
Were they open?
Yes. I can hear you.
You wrote this down?
Yes.
Let me see. This problem right here. You got 6x plus 3 on there. Let me see. Don't write nothing. Let me see. Where is it?
I was driving.
Where is it?
I was gonna write it. I can hear you.
Get to work. Not playing with y'all today. Where is this?
I wrote everything.
Where is this?
We just started writing this.
Alright, here we go. 4 sides. 6x plus 3 plus x plus 6x plus 3 plus x. Azaria, you talking? Y'all understand it's 4 sides. Another way you can write it, I mean, it's up to you, but you could take 2 times the 6x plus 3 plus 2 times the x. Either one of these will give you the same values. Just depends on how you want to write it. I like the long way because I understand it and I don't have to worry about messing up with my distributing. 6x plus x plus 6x plus x is how many x's?
14.
Do you agree?
6 plus 6 is plus 12. 12 plus 2 is 14.
14x. Ma'am, what are you doing? Please have a seat.
We supposed to write twice?
Huh?
Supposed to write twice?
I did not write it twice. I wrote it 2 different ways.
No, with one of them.
I wrote it twice because it's 4 sides. Alright, so 14x plus 6 is going to be the perimeter of the figure. If you want to make sure it's right, please feel free, come over here to Desmos and put this in for y equals, put that in for y equals. If it's the same line, you know it's right. Problem number 2. Alright, for problem number 2, we have the 2 rectangles again, and they're going to give you an expression inside of the problem, Aiden. Pick up your computer. Don't touch anything. Turn it this way. You just touched the button. Close the computer screen down. Alright. Number 2. 2 rectangles. One of them may be given as 6x plus 3 and x, because that's your first one that we had. But then rectangle B is given as x plus 4 and 3x. What we need to do, let me show you. On this problem for number 2, right here, they're going to give you the expression that represents the difference between the total areas. This is the expression that represents the difference between the total areas, and you got to find out which expression is equivalent to that one. Very simply, go over to what? Desmos. Type in the expressions and see which ones will come up equal. I'm going to show you how to do it after we write it. Alright, so the expression that shows that these are equal is bracket, parentheses, 6x plus 3, close parentheses, parentheses, x, close x, minus x plus 4 times 3x, parentheses and bracket. That's an example of what they have on the assessment. So they found the area of this one, the area of that one, subtract them, and that's the difference in the 2 areas. Put this in for y equals. They give you 4 choices. My question is this one a solution? Does 3x squared minus 3x minus 4 represent the difference? Alright, does it represent the difference? What you're going to do is go to Desmos, type both of these in, put them in for 1 and for 2. Tell me if you get the same line. Yes, put this in for y1.
Okay.
Put this in for y2.
We got the brackets too?
Add the brackets. Somebody's talking while I'm talking, and I said no talking today or else you're going to be put out of here. Huh? Where? Right here? Erase that.
Oh, okay.
It's putting it at the subscript for me. I don't know why. Oh, no, it's gotta be wrong. Okay.
Alright, I'm going to move this over a little bit so I can open Desmos on here too.
That says 4, right? Or what?
Alright, y equals bracket, parentheses, 6x plus 3. Come here, you three. Come here. Amara, Zara, come over. Go find Mr. Cleveland. Tell him you need help getting back in class. Alright. Times x minus parentheses x plus 4 parentheses 3x bracket. There's the quadratic. Now you're going to put in the second one. Is 3x squared minus 3x minus 4. Is that the same?
No.
It is not the same. Therefore, that is not the correct answer. So what you would do is try the next one.
We tried the parentheses thing, right?
I do notice that I know that somebody forgot to put in an X when they typed it in. If you forget to put in the variable, it's not going to come out right. All right, any questions? All right, number 3.
So just type in each answer. Make sure you can see
This is not right. So try another one. Okay? All right. Well, right. I'm going to come back to it. Look, I'm saying, like, if the first one don't work, then try the second one. If the second one don't work, try the third one. But make sure you put y equals in front of it.
Okay, so all this is just matching with one another.
Yeah. All right, number 3 and 5. Number 3 and 4. Number 3 and 2. I think that might be all we have to write down. The rest is probably just reviewing what we already did. Hopefully in a minute. Did y'all hear me when I said we need to make sure we got all the questions done? Didn't I say that? How many times I got to say that? All right. Are we still on the first question? You ought to know. You paying attention. Number 3. All right. The area is modeled by this quadratic. Choose 2 expressions to represent the dimensions. Here's what we need for this question. Number 3. Given y equals x squared minus 12x plus 36, the factors are who and what? All right, so if the factors are 12 and 3, how do you write it?
12 negative? No. Wait. Yeah.
Wait, that's not right because that won't give you the minus 12 and the, it's got to be 6. I don't think you put it in the calculator. Okay, but I'm going to say that the factors for the sides of the rectangle, the factors for the size of the rectangle are equal to the opposite of the zeros. And then you write the opposites as factors. I feel like I'm teaching math 101. For real. Yeah, so what happens on this problem is you have a rectangle. The area is x squared minus 12x plus 36. You put it in decimals for y equals. It's going to give you a graph. I think this graph just touches at -6 and -6. So this graph is just going to touch at -6. And it goes like that. If the graph touches at -6, what are the factors of the two? What are the length of the two sides? If the zero is at -6, what is the factor? Right here. Remember the zeros were at -3 and 4, so the factors were x plus 3 and x minus 4. If a factor is at -6, what is it? No, it's not. X plus 6. So this side is x plus 6, and this side is x plus 6.
See, I just keep forgetting to put the x plus.
And that's it. So when you come over to decimals and you need to write the factors are the lengths of the sides. So y equals x squared minus 12x plus 36, and then y equals parentheses x plus 6 parentheses x plus 6. That's not the same line. Now that's not correct. What about x minus 6 and x minus 6? Is that better?
Yes.
Yes, that's better.
Oh, so how did we get the wrong answer?
We got the wrong answer because when I graphed it over here, and I should have graphed it over there.
Oh, so we graphed it. Oh, you graphed it.
I graphed it wrong.
Yeah, you did.
All right, are we clear? Questions?
Can we start?
Let's get ready to take this assessment. I'm getting ready to give this quiz.
Okay, so Mr. Cleveland is actually involved in something. I intercepted them on the hallway.
Okay,
You call their parent, send me an email with their names, and I will also follow with the parent.
thank you. Come on in. All right, illuminate. 20 minutes. 5 questions. Yep, I think you got it. You can use your notes. I've had some hundreds, okay?
Wait, can you show the I didn't.
Huh? What kind? Yeah. Yeah. Go back. No code. Go straight to the portal.
Is there a code or?
No, go straight to the portal.
Okay.
Please stop talking. Please stop talking. Please stop talking. Go to the portal and take the assessment. The lockdown browser. No, go directly to Illuminate. Circle or flat? You can go over to the table and sit there and borrow mine.
Just wants to apologize to you that you feel like I was talking. She hit me with her bag and she said, "Excuse me," and I said, "Okay."
Thank you.
So that's if you saw me talking, that's what I was saying. Okay.
I appreciate it.
I wasn't talking.
All right. Get to work. Stop talking, please.
I gotta wait till somebody else finishes.
All right.
That I'm not coming today so I can do my test.
What?
Can I just say which I'm not coming today?
You know, it's like 119 and it says it's only 5 questions. 11:19.
Either.
Thank you. Not a problem. It's off. That's not what we're doing. Come on over here. Hmm? In the bottom drawer. Hey, did you get a circle charger? Uh-huh. You asked me for one?
I asked you one, you said you didn't have one.
It's a better than about the Kamaria. Bring 2 circle chargers and give one to Alan. Alan. My back hurts so bad.
It don't work.
Okay, I see some green. I see some green. Close that out and go back in. Girl, turn this off. Oh, because it's right here. You got it open twice? Hmm. Let me turn it off.